This video is going to look at the string class. We'll talk about passing primitives, the string object and the methods, the equals method, and how to deal with equality when the data is doubles or floats. Terms you already know are objects. We've been talking about that most of the semester, but remember that objects have data and behaviors or methods. A class is the source code that describes the object. It's the methods that are the behaviors and the variables that hold the data. A string, as you know, is a sequence of characters and an instance of a class. You created an instance of class last week with the scanner object. Some new terms we're going to introduce this week are exception. So when you have a runtime error, Java is going to call that an exception. And it's not good. We do not want to write programs with runtime errors. So we'll take a first look at exceptions. An immutable object is an object that cannot be changed, and strings are actually immutable objects. A token is a single element of input, and usually a token will be separated by white space, and a white space is simply spaces, tabs, new line. When you pass a primitive variable, such as an int or a double, their values are going to be copied. They do not get modified. We have here our main method, and in our main method, x is declared and assigned the value of 23. That 23 is sent as an argument to this method strange. Notice that strange is going to modify x. Same variable name. As you know, this does not need to be the same variable name, but in this case it is. So x is now 24 in this method, and we'll print out, and out prints x equals 24. Here it is. We return, because we're at the end of the method, we return, and now we're going to print again. We're going to print 2. X is, now what do you think? Is it still 24? No, it's 23. This method is actually making a copy of the data, and the data is sent by value. That's what the word value is semantics means, that the value 23 is being sent to a wholly different RAM location. If this RAM location gets modified, it doesn't matter because this RAM location is still the same. Now, the emphasis this week will be on strings, and a string is an object. It's not a primitive type. Did you notice when you declare a string, you're using a capital S? And we also mentioned that when you create a class, you're going to use a capital letter. So a string is a class. It holds character data, and this is an object. It's going to have properties, which is the character data, and methods, which is behaviors. And we'll go through some of those methods. And you're going to have a lab in which you're going to run a lot of methods of the string. To declare an object, as you know, you're going to write scanner input equals new scanner. But a string is going to be different. In a way, a string does act a little bit like a primitive data type, because to declare a string, you don't have to say string some characters equals new string. You could, though. All you have to do is write string some characters equals, and then put the string in there in the assignment. It also has some operations like a primitive data type. For example, most numbers have addition, subtraction, multiplications. Those are called operations. And a string has the operation called concatenation. You've been doing it most of the semester. We use the plus operator, and it just means to join strings together. So here I have an example. We're declaring a city string, Moline, a state string, Illinois, zip string, and I made a little reference here because I've taught databases for a while, that even though the zip code looks like a number, do you ever do math with a zip code? So a zip code is a string. So I've declared the zip code as a string, and here we are concatenating Moline, concatenate it with a comma space. That'll be Illinois, a space, and then the zip code. What is an index? In order to understand how the string methods work, you need to understand this concept of index. In a book, for example, an index is how you look up something in the book. And that's what an index is too with a string. As you know, a string is simply characters, a set of characters. To be more specific, a string is an array of characters. So we're going to use this index here to look up one of the characters. Each character has a cardinal number associated with it, beginning with 0. If my password were zebra, like this, the index for Z is 0. 1, 2, and you just continue like that. And I want to note, first index is 0, not 1. And this is typical of arrays. It has to do with the offset memory. We'll learn more about that maybe next semester. So the first string method I want to look at is char at. This is the method header for char at. Now take a look, and I want you to think, what is the data type? Looking at this, what data type is being returned? Char. Secondly, what is the data type of the arguments? When you're calling the method, you have to call it with an integer. And thirdly, what do you think might happen if that integer is larger than the size of the string? Or more technically, we're going to call the length of the string, because there's actually a method called length. It's not going to be good. Here is a method called length. It's actually lowercase l. It returns the number of characters in a string. And here is the method header, public int length. So what is the data type of the return value? It's going to return int, the number of characters. What is the data type for the argument? No, it doesn't need an argument. What do you think it means if length returns a 0? Well, it means that it's an empty string. It's a null string. There's nothing in the string. We call it an empty string. I've got a string S. What would be the length of this string? Well, it's simple. You just count how many characters. 1, 2, 3, 4, 5, 6, 7, 8. The length of this is 9. What are the index values for that string? This is going to be 0. Always the first one 0. If the length is 9, guess what? That's not 9. It's 8. So the greatest index value in an array, in this case in the array of characters here, is 1 less than the length. Here is an example of using char at. So I have my password zebra. I'm going to print it out. I'm letting you know, spaced out password. Here's the output. And we're going to actually loop, and one character at a time, print it out and print 5 spaces in between it. So the first time through the loop, I is 0. Now what I want you to notice is that to call the method, you're simply using the name of the variable, the string variable. Then you're using the dot operator followed by the method name. And in this case, remember, you need to send an integer to it. And the first time through the loop, I is 0. So it's going to grab that Z. That's all it's doing. It's returning the Z and it's outputting the Z here, followed by 5 spaces. Now I'll loop back up. What happens to I? I becomes 1. And this one's 1. And I think you can see what it's going to do. I want you to notice that instead of writing while I is less than 5, we're going to say as long as I is less than password.length. So the length of this is 5, but we're going to make sure that I doesn't go to 5. Do you notice this does not say less than or equal to? So we're not going to get the character that does not exist. This is a nice way to loop through an array. Here's another method called the substring. A substring is simply a portion of the string. So to make the method call, you have the string, which is probably the string variable, dot substring, and notice there's 2 arguments. The start is the beginning of the string where you want us to pull it out, and the end is optional, but the end, if you include it, will be where you want it to stop, but it actually stops 1 character before what you put in the end. If you don't put the end position in, notice it says up to but not including. If you leave it out, it's going to take from start all the way to the end of the string. Well, we need some examples of this. I have my string zebra, bang, pound, elephant 2. And we just want to grab elephant out of there. And the E starts at index 7. And the T is at 14. But the second argument is, what does it say here? It says end position up to but not including. If I wrote 14 here, it would just bring out elephant. What we're going to have is 15 as the second argument, which is the 2. So it goes up to that, but not including that. Notice that password is the name of the string variable. Password's what we use here. Here's the method name and our arguments. I want to demo for you what's going to happen when you exceed that. So this is index 15. What if I tried to access, what if I wrote 18 here? In fact, I did this and I wrote 22 and I executed this. And this is the output I got in NetBeans from the output window. Have you seen this? Have you had an error like this? So this is a runtime error. My program did compile. That's good. But when I'm running it, it got to that part of the string and it said I can't do that. This is called stack trace. And I can use this to help find where my error's at in my program. A lot of these are in the library. JDK, you know, all these are in the library. Here's java.lang. Remember java.lang from last week? And finally, this was the name of my method. Well, the package was miscellaneous 2. That's just what I call the program. I'm in the main, and it happened at line 24. So sometimes when you get this, you can click right here. These are all hyperlinks, but you don't really care about the source code here. You can get to it though, but this is going to tell me exactly where my error was at. In the previous slide, the error message told me what line the error came from, and the verbiage was, let's look at it again. The verbiage was an exception in thread main java.lang string.index out of bound exception. And it's telling me here that you can't go beyond. The length is 16. Line 24 threw an exception, or you can say an exception was thrown at line 24. The type of exception that was thrown, you can trace where the exception started here. So the exception started getting thrown from here and it just got passed along. It's like a baseball team throwing from catcher to first to second to third, throwing it along until it hits my code and then explodes. And I could have handled it, you know, because that's what they're doing. They're handling this. And I dropped the ball here. An exception is what happens when you have a runtime error. I kind of alluded, they can be thrown and they can be caught. And the process of being able to catch your exception so that the runtime error doesn't happen to your user is called exception handling. Here is a table from the textbook with different methods. And these aren't all of the string methods, but we've looked at char@. Here's examples in the third column. Shows you what the method will return. And we're assuming that the variable s has hello in it. So char@1, well, that's 0, that's 1. It's returning an e, okay? And s dot ends with LLO, does it? Oh, yeah, so that's true. I don't know how often I'd use that one. But hey, where is O at? What index value is O? And that will return 4. And what's the length is 5. And I want to replace this. I'm going to take the L out and put YY in. So it goes to this L and puts a YY in. And it goes to that L and puts a YY in. And this is what comes out. Does it start with high? That's false. Give me the substring 1 to 3. So 1 starts with E, 2, 3 is that L, but remember it doesn't include that one, so EL is what is returned. There's also a 2 lowercase and a 2 uppercase. Let's take a look at some of these methods. I have a string called S1 Paris, France, and this is just kind of the index above each one of these. And here's string 2, Washington, D.C. And what's going to output for the length of what? Well, see, string 1. What's the length of string 1? And it looks like it must be 13. Notice the last one is 12. The length is always one more than the last index, so the length will be 13. The second one, print out the index of E. Well, that's going to be 12 for S1. Now print out the substring of S1, 7 to 10. Well, 7 is F, 10 is N, but it doesn't include that one, so FAR will output. And now we're going to string S2, and we're going to assign it to S3, the substring 11 to 15. So here's 11 is D period C period, and then we're going to take that and we're going to lowercase, and so what's going to output is the lowercase D period C period. How about this example? I have this string. How would you grab Java? I just want to output the word Java. You know what method you're going to use? Take a look at maybe one of these methods, and I hope you think substring method. So the substring, the argument is going to be 9 to what? 13. Now, when you call these string methods, you are not modifying the strings that the methods are called on. What are you doing? Let's look at the previous slide. Now, when you call string methods, you are not modifying the strings that's making the method call. In the example here, you are just simply printing it out. In this example, we are pulling a substring out of S2, the DC, but it's not modifying S2, it's being assigned to S3. And here, S3, if I printed S3 down here without the 2 lowercase, it's still capital D period, capital C period. In this example, we've got little bow wow being assigned to S. This does absolutely nothing. It's not changing S to capital little bow wow. It's actually really doing nothing because you're not assigning it to anything, you're not printing it. In the next statement, when you do print out, it's printing out little bow wow in that format, even though in the previous statement you had done to uppercase. If you really wanted to print it out to uppercase, write to uppercase right here. To modify a variable's value, you must reassign it. So in this case, yes, we got the same variable. S to uppercase, uppercases it, and then it assigns it back to S. Now when we print it out, it is all uppercase. Hope that makes sense. There are more string methods. You could look at Oracle. So here are some of the methods that are in the string class. Here is a description of those methods, and this is Oracle's help for Java 19. And here's more at W3 Schools. So there's many more than what you see in the book. Wow, there's a lot of methods for strings. You will be working on a lab in JShell, so you'll be entering in JShell some of the string methods to see how they work. Since we're talking about strings, I want to talk about the equals method also. For you to know that there is a class at the top of the class hierarchy called objects. And in this class, object, which is inherited by all classes, is an equals method. And the reason for that is we have 2 relational operators that checks for equality and inequality. This compares 2 values to see if they're equal, such as, does 5 plus 1, is that equal to 3 plus 3, which would be true. And we're going to go into relational operators a little more next week. These operators work fine with primitive types, but not necessarily with objects. Sometimes they work as expected and sometimes not. And since a string is an object, don't use these operators because your program may be buggy. For example, suppose you prompt for a password and you need to check if the password input by the user is equal to the password in the database. I would not use this operator, so the solution is to use this equals method. And for any object, including the string object, the equals method will compare the 2 strings and return true if those 2 strings are equal. By the way, this will be a case-sensitive comparison. So here's the syntax for the equals method, which is a method of the string object, since string inherits from object. And again, let's go through this. What is the return type? And it's going to return Boolean, and a Boolean is true or false. And what is the argument type? It's another string. So if I have two string variables, say string user password input and the correct user password, and I want to see if they are equal, what I'm going to write is something like this. User password input is a string variable. And as a string object, it represents a string object, I can use the dot equals operator, and then the argument is another string. So this is the same as saying, does user password equal correct user password? And then if that's true, if this statement is true, we're going to do statements here. Otherwise, we'll tell them that it's an invalid password. Here's that statement again, but if the user password input is zebra and the correct is zebra, notice they're different case, and this will end up as false, as I said. So when you're working with equality among strings, there's even an extra special equals method. It's equals ignore case. So if you did user password input dot equals ignore case, and then send that argument, it's going to compare them and ignore the case, and that will return true. A lot of times passwords are case sensitive, but sometimes case gets in the way of doing your program correctly. So just be aware that that is an option. While we're talking about equality, one more thing to add is, as you know, this means are both sides of this expression the same value? This operator here means not equal to. If you look on your keyboard, there is not a not equal to symbol that we're used to in math. So we use the exclamation mark and the equal to sign for that symbol. And if they're not equal to each other, the expression on either side of that operator are not equal to each other, it'll return true. If they are equal to each other, they'll return false. Kind of the opposite. Of course, they're the opposite. One's the not of the other. But when you're using equality with floating point numbers, which numbers with decimals, data type double, data type float, for example, you may think the values should be true, but the way that binary numbers are storing decimal values, it's not exact. So sometimes you might have a 0.000000001, and it's kind of like our little rounding error. But when you're testing for equality, that rounding error is not going to make that comparison a true comparison, even though it should be. So when you are testing for equality in floating point numbers, you're going to do this. We're going to take the absolute value, we're using the math object, and here are two decimal variables, say doubles, and we're going to take the difference between them and see if the difference between them is a minute amount. You get to decide the precision here. You know, for dollars, I don't think you round 1/1000th of a dollar, so that's probably okay. And if this returns true, now we're going to assume that the difference was a rounding error. As again, you get to decide on the precision. If you do this, there's a very good likelihood that you may have a rounding error and something that should be true will be false. So there's a lot more of false negatives, okay, that they should have been true and they'll be false. Let's finish this video up with this problem, because these problems will be similar to some of the questions you have on the midterm. I will be doing a video next week when I present the midterm. There will be a practice exam, and I'll go through each of the questions on the practice exam to answer how to do that. And please look at that when you get ready for the midterm. So we have here a class with main, and main declares 3 integer variables. We also have here a method called mystery with 3 integer arguments. Notice the order of the arguments. This is going to be something you will need to pay attention to. Mystery is called, now this question might be something like, what is the output of this? And notice the output's happening down here in mystery. On the midterm, the output could be happening up in main. You just have to know how to read the source code and see what's going on. So mystery is called sending Z first. It's not going in XYZ order. That's what you got to pay attention to. So Z is 5. 5 will be written to X. In mystery, it's going to take the value of X. And then we're going to send Y, and Y is 2. Well, notice 2 will be assigned to Z in mystery. And then we're going to send X, which is 9. And notice that will be assigned to Y. Next, we're going to print out Z. Well, what's Z? Oh, Z is 2. And the word and. Don't forget that. And there's a space on each side of and so that the number and the characters don't run into each other. And then we're going to do this little arithmetic. Y, 9 minus X, 5. And that will be output, so 4. That statement will execute. And it's done with that. And it'll come up and say, well, we've done this step. Let's do this step, which is another call to mystery. I'm going to erase this. And we'll do it again. Mystery is called, now we'll send Y first, and Y is 2. Then we'll send X, and X is 9. 9 is being assigned to Z. And then we'll send Z. Z is 5. Z is being assigned to Y in mystery. And so we'll print out Z. What's Z? 9. Print out and. Remember, this is string concatenation. And then we'll print out Y minus X. So 5 minus 2, 3. And that method's done. And we come back up here, execute the next statement, and we're done. So if this question were on the midterm, this would be the answer you would be providing. There's one quiz this week. Take the quiz. It's over the content of this material. Good luck.